Hi, and welcome back to Rock the JVM's Scala at Lightspeed. I'm Daniel, and in this video we will discuss one of Scala's most powerful features, which is pattern matching. Now, I'm going to go back to the project that we created at the beginning of this mini course. And if you are new to this video series, go back to the beginning of the course where we set up this initial project and we discussed the infrastructure that we are going to use throughout this series. Now, under the package com.rockthejvm that I created at the very beginning, I'm going to create a dedicated application for this video. So I'm going to right-click New, Scala class. I'm going to name this pattern matching. I'm going to make it an object as we did with the previous applications, and I'm going to have it extend app so that we can actually run this. So you can run this on your own computer if you want to test some code. All right, now the first thing that I'm going to talk about pattern matching, and let me collapse my menu so that you can see my code, is what you may have seen in other programming languages like Java or C or C++, which is the switch statement. So I'm going to use pattern matching as some kind of a switch expression. What do I mean by that? Let me create a value of a type int. Let's call this an integer as having the value 55. Now, you can match this integer against a number of cases instead of using if-else chains. So let me give you an example. Let me define a value called ordering or order as, and watch what I'm writing, an integer space match, which is a keyword in Scala, and then I'm going to open and close some curly braces. And inside, I'm going to add cases. So in case I get 1, I will return the string first. In case I get the integer 2, I'll return the string second. In case I will return the string third, and in case I get everything else, which is denoted by this underscore, the equivalent of the default case in the other languages, I will return an integer plus the suffix th. So if I want to print line this order value, so print line order, I will return 55th, which is the description of the number 55. It takes a bit of time to compile. So 55th. Now, notice that this pattern match structure is actually an expression. So pattern match is an expression. Much like anything else in Scala, that means it can be reduced to a value. So the value of this pattern match expression is either the string first, second, third, or the string composed by the integer plus the suffix th. And because it's an expression, we can assign it to a value. So pattern matching is the equivalent of a switch expression that you may have seen in other languages. But pattern matching takes things to a whole another level because pattern matching is able to also deconstruct data structures into its constituent parts. Let me give you an example. Let me create a small case class that I'm going to name person, which has a name as a string and an age as an int. We discussed about case classes in the object orientation video in this mini course. So if you don't know what a case class is, go ahead and watch that video first. All right, so having defined this case class, I will create an instance of that case class. Let me create a value called Bob as a new person with the string Bob and age, let's say 43 or something like that. You know from the object orientation lecture when we discussed case classes that they don't need to be instantiated with a keyword new because the person case class also has a companion object with an apply method. So this is actually person.apply with the string Bob and the age 43. All right. Now, that's not the goal that I wanted to show here for the case class. What I want to show is how to deconstruct a value that you obtain from somewhere else and decompose it into its constituent parts. Let me give you an example. Let me create a string called person greeting as Bob space match and opening close and curly braces. And I will add my first case, but instead of passing a definitive value as we did above with the switch expression, I'm going to pass a whole structure like person with a name and an age. And I will return the following string. Hi, my name is $N. So the ID has already created an s-interpolated string for me. My name is N, and I am age years old. This is more like a kid's greeting, but you get the idea. So this case over here is not necessarily matching against a definitive value like we did above, but it matches Bob, the value that I'm matching against a whole entire structure. So if Bob conforms to the structure person with a name and an age, then let N and A be the constituent parts of Bob as a person. So if I have N and A as the constituent parts of person, I can then reuse them at the right-hand side of this arrow sign. And obviously, in case I get something else, I will return something else as the string. So if I print line person greeting, you will see, hi, my name is Bob, and I am 43 years old. That is because the pattern match expression is able to match Bob against this structure, and it will automatically assign N to the string Bob and A to the number 43, and it will inject them into this s-interpolated string. So if I run this application again, you will see, hi, my name is Bob, and I'm 43 years old. Now, in the object orientation video, I mentioned that there are a couple of benefits to defining case classes, and one of those benefits now is being able to deconstruct them in pattern matching. So pattern matching is available mostly for case classes. It's also available for normal classes if you do a lot of magic behind the scenes. I'm not going to talk about that because that's really advanced. So just bear in mind that pattern matching is only available for case classes for now. Good. So pattern matching can deconstruct case classes. Now, pattern matching can deconstruct some other data structures as well. For example, deconstructing tuples. So let me create a tuple as the tuple Bon Jovi, which is one of my favorite bands, and the genre rock, for example. You know from the earlier video that we can create tuples by putting some values here separated by comma inside these parentheses. And this is a tuple. You Python users, I'm sure you know what I'm talking about. Now, Scala can deconstruct these tuples into their constituent parts. For example, let's call this band description as a tuple space match, and open and close some curly braces, and I can pass in a case that describes the structure of a tuple. Let's call this band, comma, genre. And on the right-hand side of the arrow sign, I will say that band belongs to the genre $genre. And in case I get something else, I will return the string, I don't know what you're talking about. All right, so if this tuple conforms to a two-member tuple structure, then let band and genre be the members of that tuple so that I can then reuse them into this s-interpolated string. So notice how I'm reading this pattern match expression. If the tuple conforms to this structure, then let these be the members, the constituent parts of this tuple so that I can then reuse them on the right-hand side. You can also deconstruct more complex data structures as well. For example, decomposing lists. So let me create a list as the list 1, 2, 3. This is a list of integers. So if I create, for example, val list description as a list space match space open and close curly brace, I can create a case that describes the structure of a list that takes something, so the underscore means absolutely anything, the number 2, and something else. And I will return the string, for example, list containing 2 on its second position. And in case I get something else, I will return unknown list, or something like that. The underscore presence is not mandatory, but if the pattern match doesn't match anything, it will throw a match error, which will crash your program. This is why for best practice, we normally always add an underscore case over here. Good. So notice how we can describe some complex data structures, like a structure of a list whose first element is something that we don't care about, the second element is 2, the third element is something that we don't care about, and that's it. So a 4-element list will not match this pattern, a 2-element list will not match this pattern, and so on and so forth. The list must have exactly 3 elements, the first and the third of which we don't care about, and the second must be exactly 2. So notice how pattern matching is much more powerful than a simple switch. One more thing about pattern matching. Pattern matching will try all cases in sequence. So for example, if I inverse these cases, so if I put this case first and the case with the list of 3 elements last, because this wildcard, this underscore matches absolutely anything, the string that will be returned is unknown list. That is because pattern matching will try all the cases in sequence. So let me change that back. Now, I will end this video with the fact that pattern matching is much more powerful than we've written here, with lots of complex data structure deconstruction, name binding, and so much more. But just to quote Tim Ferriss and his minimum effective dose, this code is basically everything that you will need to be able to work with 90% of all pattern matching use cases that you will ever see in code bases. Alright, so I hope this was useful. In the next video, we will talk about some advanced Scala stuff that you will probably see in real life. If you liked this video and found it useful, go ahead and click the like button and subscribe to the Rock the JVM channel, and I'll be posting more free goodies here. This video series is also available as a free online course at rockthejvm.com, where you will also have the option to download these videos for your offline use. And on the Rock the JVM site, we also have hundreds of hours of premium content dedicated to Scala, functional programming, Akka, Apache Spark, and so much more. So go ahead and check out rockthejvm.com, and I'll be waiting for you in the next video.